Okay, this is what we're gonna do. I got a new program. We'll go straight to it. This is what I call CNC and pick and place. So technically, what's going on here is you have two CNC machines here. This one's gonna make a lid. It looks like this lid, green lid right here. We have one right there, and we have a base right here. So this right here, machine right here, is gonna be making this lid, and the one up there, right here, is gonna be making the base, which is the bottom part. So how this part works is it will make the lid and the base, and at the end of the conveyors over here. Oops. At the end of the conveyors over here, it'll basically stop right here for the base and stop right here for the lid. Then I'm gonna have my robot pick in place to basically assemble it. Once I assemble it, then I'll just release it, go to the middle conveyor. And how the lid work is basically it'll go like that, and it'll just drop on top of it. I'm sure you get the point. It's basically like a Lego part, but that's the theory. So let's get rid of that. And I do have these vision right here. For now, I'm not using this camera um, because these lid and base have different colors. They have green and blue. Mm, I was in the process of trying to assemble only blue lids to a blue base and green lids to the green base, but I just added these in yesterday, so I didn't have time to add the code. Um, Here, I'll show you the program. And right here, CNC robot. The upgrade is going to be the one with the vision, and I have a bunch of additional stuff, uh, additional pallet, uh, conveyor belt, and to put the box parts into the pallets and pack it. But that's for another video. But for now, we're just gonna see how this automation system works. So this is how you basically this is how you simulate using Siemens TIA portal. So you basically start a new project. What you'll do is project, and you just click on new. Um, then well, I mean not new, but you download the factory IO template. It's back over here. You click on Siemens right here, and it shows you what to how to set it up. Set it up in here. Let's say you want to set up S712 or 1500, which is the top of the line. You want to set it up, and it basically tells you how to do everything. And you got like instruction for dummies. There's no way you can't figure it out. It, yeah, it basically tells you everything you need to know. And they actually have a template that you could just download and use that template and just go straight programming. You don't have to add the hardware uh, right here. If you want to download it, you basically just download these, and remember, go by your version. I'm using version 16, I think, which is the latest. If you have a 14, make sure you use the V14 version. If you have 15, make sure you use the V15. I think 15 and 16 are pretty much the same because they made it to work. But 14 down and 13, you have to have a separate template file. So let's say you download that. basically what it will look like is, let me open it to you. Alright, template right here. I have a template from my version 15 and or 16. So if you open that, all it's pretty much what the template does, it basically add a configure uh, hardware for you, the CPU and the in and output. But that don't really matter because you can add as much input output as much as you want. But what's really important is this line of code that Factory IO add in to make it work with their software. And you do not want to delete this line of code. All of this value are basically is what making it work when you simulate it through POC sim, the simulation. Now, if you want to use your actual hardware, then no, you don't need this template. You just basically hook it up straight with your actual hardware, and you just basically run it like it is, and you set it up in your factory IO. Of course, just go through the manual. It'll show you how to do that as well. But for now, we're just gonna simulate it through the simulator right here, because I don't expect everybody to have their own hardware. I mean, this 1500 series is like $2,000, so I don't expect anybody to have that unless, you know, I don't want to know how you got it, but that's my point. Is we're focusing on the simulation. So let's open up my program again, and I am using the template. You can see I still have this line of code right here, and I just basically add a bunch of blocks. So I left that part in, but I have to do my own programming, right? So I have the main assembly block. This is basically all the main part of like the input and output, what happens, basically I'm watching the robots, I'm comparing things, and I'm doing some stuff. Blue lid, green lid. Here's this line of code is I'm temporarily, trying to sort color, but I'm not done with it yet, and I haven't added these output to anything yet. It'll be for the next video, but for now we're just gonna assemble the lids, and we'll just stick to that. So I don't know how much everybody knows about ladder logic, but there's a bunch of videos about it. But basically what I'm doing is I am using a shift left register to do a sequence output. So whenever I meet all my interlocks or all of my requirement, I basically want to add a hex word of 1 into my robot assembly, and I made a word uh, right here, assembly point. It's just a 16-bit word, and I could basically uh, add hex bit to make to add it to it, and turn off the first bit. Then I'll just use the instruction to basically shift it to the next bit to the left, and the next to the left, next to the left, and it works like right here. This is how in my opinion, I work at Denso and Bosch, but Japanese, the way they taught me how they do sequential programming is using a shift left register, and when you add a 16, if you look at a calculator, I think everybody knows uh, POC, hex, and decimal and binary, all that. But just a quick example, if you watch the hex right here, if I add 16, 1, let's start this bit. Then if I shift it, it should be 2 right here. So if I turn that to 2, you get that 2. And it just doubles in a byte. So it should be 4 right here. And it should be 8 right here. Then after that, it's not 16. It goes to 10. So the next bit will be 10. So depending on which bit you want to start, you just add a hex of 10, then it'll just basically start this bit. But if you want to start here, you add a hex of 1. And how you do that is, you saw it earlier, you add a 16 hex of 1. And if I want to do 10, basically 16 hex of 10. You know, you get the point. But this is how I normally start my first bit and my assembly robot, data block robot assembly. Then my actual word is assembly point. So if you follow it, robot assembly right here. If you go to it, then my actual word is assembly points. So it's just a big old 16-bit word. Alright, you get the point. So I want to use this, and I only want to do one time every time it activate it. If it activates it, just go to the next one. And the output is basically the same word. So if I start this with 0 and I activate it, it'll be 1. And activate it again, it'll just be 2. And it'll be 3. It'll just basically refresh it, update itself. You could change this to 2. It'll, instead of going to 1 to 2, it'll go to 1 to 4, then to 10 and 40, I think. But you get the point. This, if you want to learn how this instruction works, of course, you could click on here and just F1, and they'll tell you how to use it as well. But it don't tell you how to use it like this though. It shows you the logic on how it shifts, but the way they program it is kind of different from the way I do it. This, I find out this is the best way. You want to use your actual assembly point, and you use slicing to get to that. You have to Google it. How do you use slicing bits in a word? And just Google that. They'll have like a little picture, looks like this. You see that, right? So this is how they do structure slicing on Siemens right here. This is the main thing you want to use. So let's say if you have a word tag, right? You can't really just say, you know, let's say my word tag is word dot, you know. You can't just say word dot XO, word dot X2. You have to add like your name dot, the percent sign, X1, which is the bit 1, you know, or XO, it'll be bit 0. So kind of study this little diagram. But back to the main point. Alright, I'm gonna simulate it. So we're gonna click on this, start simulation. We're gonna simulate that. You know, this little screen's gonna pop up. This crap, I need to close all of these. Alright, do it again. Okay, when you click on that, you're gonna get a little box. This is your little virtual PLC. Alright, it's gonna pop up. And it's gonna want to search for it. So, you look for your simulator. It should pop up right here. Just use the common CPU common. Load it. Don't do anything. Just say load it. And at the end, just say start module. Start the module. Finish it. So basically now it's gonna go from orange to green over here. So now it's running. So it's running in the background right now. You can prove it by monitoring. You can see all of my green is ready. The main part is all green. You can see it's all ready to. Okay. So once you got that going, open up your project in there, and the way you set the simulator, you have a bunch. Okay. we're not using, this is for the actual hardware, the S7-1200. You want to use PLC sim, and you configure it. This is what I was talking about. You want to use uh, S7 1200 or 1500. Just make sure you got the right version that you need. Mine is 16, and I got the template to make it work. So they only have this three options. So I have to click on this. The reason why my version 16 is working is, remember, it's the template that I download. All right. Okay. So we got that auto connect, and this is what I mean. You can add as much um, input and output as much as you want. You have a offset where you want to start and how many you want. 24, 24. I didn't want that much. And this is all of my IOs. And you got to remember, Siemens only have a byte of actual hardware, so they only have like 8. So basically, all start from 0 to 7, and 0 to 7, 0 to 7. And in real life, it's gonna be like that too for the actual hardware I/O. Okay, so you saw that I have a green check. That if you see that, I mean you are connected. If you don't see that, then go back and check all your configuration. Make sure you did it right, and read the manual and try to figure it out. All right, so I got all of my in and out. You could basically set these, where you want it. Say I want this over here. It'll be over there. I don't. You just basically drag and drop, and all the blue is either analog or digital, double integer, real. It depends on what it is. It could be timer. I mean, it could be counter. It could be a vision. It could be a camera. Whatever it is, analog. You put it on these right here. Yeah, I got all that sorted out. All right, to the fun part. Make sure I'm still recording. Okay, I am. All right, let's test it out. See what it does. Okay. That's basically all it does. Uh, that's pretty much. It's gonna do that over and over and over. Um, I'll make another video explaining more on the automation side, but this is particularly for how to set it up in simulation mode. Um, but yeah, that's pretty much how you start with from scratch and how to get it running. And the way I do it, normally I would just go to driver from all my IOs, and I'll just drag and drop everything that I'm gonna use, and I'll just basically go to the PLC tags, and I'll I'll just basically copy all the in and outs in the name of it. So let's say we are starting at IO.O right here. See, same thing, list and entry, list and entry. CNC busy, you know, IO1, you know, you just go down the list. And, you know, x-axis position, right here, ID 30, This, you know, Rio, ID 42, digital, double integer, you know, double integer revision, ID 42. It's common sense, just kind of copy it, and that's pretty much how you make sure everything's working correctly. Just try to make it the same thing as the factory IO. But I'll make another video explaining more on my logic side on how I make, I guess, how I make everything work, why I program it like that, why I use compare, why do I have this part right here, you know, why do I need a timer for this, you know, and how do I how do I make the robot move and all of that. I'll do another video for that part. I'm running out of time. But yeah, y'all got any questions, just drop it down in the comments, and I'll be sure to answer. That should be it for this video. Thank you guys.